Just making sure you were the one that sent the last one. So, yeah, I forgot. Straight into the You have to watch video. That's something for you. I want like picture things. So to and then I told him off each other. You know, for like nice folks. Yeah, these are the so we said, yeah, these are
Like stop it. That's like, oh, it's nice. It's fun. Why? Like, I wonder, and that's where I go. Yeah.
Yeah. That's like today.
Measuring, yeah, we did like measuring and we did. So it's like, in talking spaces, and yeah, like, right.
This is fine.
It's guys, it's a job. Yeah. And now I'm checking working and he's back to go. Excessive like everything. Yeah. That's what it does. Anyways, that was, yeah, I think it was like that. Did you do the math? I did the math. Nice. But she's not. Getting a bunch of math is the best. It's
So
like,
first one.
I really don't mind. I don't mind on people for like 3 years.
All right, let's get started. First thing first, any questions before we get started? Okay, so do you start to do your homework now for chapter 10? If you haven't, then get started as early as possible, okay? And then use the teams wisely, okay? Let's actually Q&A section over later. If you encounter problems, you can post your question over there. I'll try to answer as soon as possible. Okay. What we're going to do today is actually going to finish in chapter 10. We still have one portion I haven't actually show you how to just solve it in great detail, right? On the board is actually the things that we went through on Tuesday's lectures. So today, I think we're going to head into chapter 11 after we solving the very last one questions of chapter 10. Okay, so for your midterm one, you have 3 chapters, right? Chapter 10, chapter 11, and chapter 12. Chapter 10 is actually the one, I guess you have a good idea about the contents now, right? Concentrations, right? So the main things that are going to be tested inside the chapter 10 is really just concentration conversion. And second one is actually predict the solubility. Okay. The other one is the delta H solution. The very last one is actually colligative property. So these are the 4 topics that you will become a master for chapter 10. Okay. Chapter 11, we start to talk about the reaction rates. Okay, so you need to know what's the definition of, when we talk about chemical reactions, right? We talk about the reaction rate. Okay, so what does that mean? Okay, you need to know what is so-called the differential rate law and the integrated rate law. And more importantly, we start to actually entering a more molecular level world. We want to understand how the scientists realize how the molecules work with each other to get a reaction going. I want to actually know the mechanism. So from there, we actually know about things called the elementary step. And then from the elementary step, we start to actually derive a term for the activation energy. Okay, the larger the activation energy, the slower the reaction will be. Okay, so those are things we will cover for chapter 11. Chapter 12 is actually talking about the equilibriums. Okay, equilibrium should be actually the content that you are most familiar with because you learn these equilibrium constants when you are in high school, when you're learning the science subject or the chemistry subject. Those are things you already learned. Okay, so you just want to actually refresh your memory, redefine a few terms that sounds fancy, but it's the terms that you already know how to do it. Okay, so with that being said, you should be able to see that the things that you are not very familiar with is actually chapter 10, chapter 11. Right, so these are the two you have to spend your time and get it understood well enough. You need to know how to use the things you learn from the lecture to solve the problem. Okay, so make sure you distribute your time wisely and start early. Okay, I want to emphasize this again, that the way you can succeed in this class, meaning that you get the letter grade that you want, is don't fall behind, right? Follow the lead, okay? Do the things at the right time. So you can spend the minimum amount of time and effort to get the things that you need. Okay, so the reason I want to emphasize this over and over again is because I want to show you some numbers. So on the board is actually the average grade, okay, for the CHEM 1312 in the past couple of years. Okay, I just take the average of it. So that's actually the grade for your midterm 1, midterm 2, midterm 3, and the final. Okay, so what did you see from here? The first thing you should see is that the average is what? Below 60. Okay, that is actually about half of us is going to fail. Can you imagine that? That's scary. Okay, I want to change that. Okay, the reason I post this is because I never actually involved teaching in the fall semester. Okay, because CHEM1312 typically is actually the normal courses for the spring, not for the fall. Okay, the reason chemistry department actually opened this one in the fall is because we know we have many students. They kind of finished their study a couple of years ago and coming back. Okay, therefore, we missed some information that we should know before we can take these courses. And CHEM1312 is actually challenging simply because it involves a lot of calculations, right? Read the questions and figure out what equation to use and put in the number correctly and calculate the number correctly. That's multiple step processes. Okay, and because of that, many of us, and we may actually make a mistake in one of those steps, then we lost the whole point, right? And that's why the grade is actually not so wonderful. Okay, so compared to the spring semester, we typically have, so in the spring semester, you can add a number, maybe at least 5 to each of them. Okay, then it's actually at least half of them will actually pass. And we actually on the other side, so we're going to change that. This is actually my first time teaching the whole semester. So I want you guys to actually work with me to change that. Okay, I want to actually make everybody to get the grade that you want. But I really need you to actually work with me using my hangout, do my questions, follow the way I solve the questions. Will really get you the grade that you want. If you have problems, do come to me. I'm very available to students. Okay, so I want to help you with learning. Okay, do not give up too early. Okay, give it a good try, give it a good shot. Okay, so I know many of us, you are not a full-time student. Okay, UH is actually a very diverse university, meaning that you have many students who work and study at the same time. Okay, sometimes your schedule won't work for the things I actually do. I understand that. Okay, but I also want you to see that why do you want to take this course? You spend a lot of money on this course, right? It's actually a 3-credit course. That's actually a lot of money, right? And I believe it is from the conversation I had with my past students that the reason you want to take this course is because you want to get the degree that you want. So they expect you can change your life. You have a better life afterwards, right? So you need to be very clear that what the goal is for this action. You're going to prioritize the things that you want first. Okay, many students actually don't really see this. Okay, they just feel like I think the course is too difficult, so I give up. Okay, what's the point in the first place? What's the point you take this course in the first place? No point, right? And I hate to see that. Okay, I feel like if you already take the initiative, then let's make it work, so that you can make your money come, make your effort come. You can move forward to make your life better. Okay, so that is my true belief. Okay, so because of that, I do spend a lot of effort to create those videos, to create a hangout. Okay, not for me, but for you. I know all these things when I was young, right? Then why do I actually want to record my videos and learn how to edit the videos? For every single video you see on my YouTube channel, I edit it myself. Okay, why do I actually want to condense into a very short version for everybody to make your life easy? Simply because I want to help my students. Okay, I spend hours and hours editing those videos. Okay, so I hope that will be, it will do its part, okay, to help you to get it where you want. Okay. I want to bring this up simply because I feel like some of you cannot see this in the beginning of the semester. Okay, if you feel like, okay, I'm really falling behind, I have no clue what to do, okay, I'm not prepared to take these courses, that's fine. Okay, get prepared. Okay, if you are this actually is too much stress to you, you will never be able to actually make it, then don't do it yet. Okay, you are not ready. Okay, so life actually requires a long-term plan. You need to know yourself better. Most of the time, I feel like I know the student much better than the student know him or herself. Okay, and the reason is actually very simple because I've seen so many students, right? Like every semester, I can talk to hundreds of students. I hear hundreds of stories from you, right? So I come to see, okay, what's really going on here? Okay, do you actually spend time and reflect deeply inside to know who you are, to know what you can do at this stage? Okay. It is very difficult to admit that we are insufficient to do the things we want to do at any given moment. Okay, you need to actually learn how to do that eventually. If you want to have a better control of your life. Okay, so here, bring up this is actually let you to see that we actually a good portion of us is going to fail this class. So you want to actually spend, now it's actually week 2, right? We have 13 weeks to go. 13 weeks is actually a long time, right? Is that the time you want to spend in this class with me? Okay, you need to think about that quickly now. Okay. If you feel like, okay, so far you feel like, okay, I probably can do okay, right? I understand what Dr. Chen said in the class. then you're fine. Okay, the only thing that prevents you from keep improving is that at certain point you start to not following me, not following my instruction. Okay, and that's the time things will become problematic for you. Okay, so be alert, okay, and work with me. I want to really improve your grades. Okay, so after every midterms, I'm going to bring this result again and compare how we perform compared to the past. So I can give you the answer right now. Okay, my office hour is every Friday, 10 to noon. Okay, but if the late time doesn't work for you, email me. Make a point with me. Okay, many students already do that. Yeah, so let me 13090. All this information is also available on Teams. Okay, so I'm not sure if everybody is actually familiar with Teams, but Teams is actually the most effective way that you can connect with me. So this is actually our team site. Everybody who actually enroll in these lectures will get access to it. And this is actually the post that I tell you, you can get all the hangouts and video recordings right here. Right, so everything I say, including the lecture today, will be uploaded to YouTube. Okay, whatever I wrote on the board, it will be there. So you don't need to actually worry about like you missed the information. But also you know how to actually get into this page. You have all the links over there. Okay, and then on the other post, actually in the very beginning of the post, in the syllabus post, you actually have all the information that you need. Okay, including the office hour here too. Okay, so I would strongly encourage everybody to use this resource. Okay, I spent hours and hours doing all these things for you. Okay, so if you don't use the resource, it means nothing to me. Okay, so I really hope everybody can actually really fully use the things that I share on Teams. Okay, and here there's actually Q&A sections, right? So some students already post some questions over here, and I answer every single question inside. Okay, so use this one too. If you have questions that you don't really understand, also here, then I'll try to answer as soon as I can. Okay, I hope we can actually work as a group to really boost everybody's grade. Okay, so it is very important that you help yourself by listening to me. Okay. All right, so let's actually count the things that I want everybody to make sure everybody know. Okay, any questions? Okay, so if not, let's get back to chapter 10. Okay, so I'm going to use this again. So section ID 101312 1A785. All right, so this is again is kind of the things we use to help you understand how well you understand the material. it's multiple choice, meaning that the answer may be more than one. Very cool. So more than 100 you have answer, right? So the first correct answer will be C, right? Because your delta H solution is a sum of your delta H solute plus delta H solvent plus delta H of mixing, where we call the delta H solute as lattice energy term, and it's always positive. Delta H mixing is the hydration energy, which is always negative. If you have a positive delta H solution, that means your lattice energy is greater than your hydration energy. Okay, so another thing is that delta H solution now is positive. Okay, so you need to know you need to actually give energy to your solution so that you can actually break apart the lattice. Right. So the way those you get energy is actually from your solvent, which is from your water. So you will actually strip the energy from your water. Okay. And once your water got stripped out of energies, then the temperature of the solution, which was determined by your solvent, will decrease. Okay. So the answer will be B and C. Okay, and this process will be endothermic. Okay. So you actually get familiar with this concept. Okay, let's do the next one. So Van-Hoff coefficient is actually important term for the collective property, right? So you actually know how to calculate your I. So I give you 1, 2, 3, 4 different compounds. Okay, very well. So I think majority of you start to understand how to count the Van-Hoff coefficient I. Okay, so answer is clearly C. Very good. Next one. Okay, very well. The answer is B and D. Okay, the very last question of today. After 10. So what is actually things we need to consider? And yes, so it is not just Bangkok coefficient. It's Bangkok coefficient multiply your concentration. They will actually dictate the collective property, right? So freezing point, if you have higher solute concentration, effective concentration, meaning I times your N. Okay. So if you have higher effective molarity concentration, effective concentration, are you going to have higher or lower freezing point? Lower, right? So this one asks you to for the lowest freezing point. That means you can to find the solutions that give you the largest product of Bangkok coefficient and the concentration, right? Everybody follow the things I just said? So I times N, if it's actually the largest, then it's going to give you the lowest freezing point, right? So I times N is the things that matters, right? Let's start from the I first. Let's say A, B, C, and D. What's the I for A? 1, right? Because it's organic compound. It's not a salt. It's not an electrolyte. So I equal to 1. I is concentration 0.04. So the effective concentration is 0.04. Okay. Now for the second step, what's the I? AgNO3. The I is equal to 2, right? Because AgNO3, once it dissolves, it becomes Ag plus and NO3 minus. That, so that its I is going to be equal to 2. Okay, concentration is 0.03, right? So that the effective concentration, which is the I times the concentration, will be 2 times 0.03, will give you 0.06. Okay? So compare A and B, who's going to have lower freezing point? B, right? Compared to A, B is going to give you a freezing point, lower freezing point, right? That means 80% of us is wrong already. Okay? Let's keep going. The third one, what's the I for your FeCl3? 4, right? So FeCl3, once they dissociate, it will become Fe3 plus 3Cl minus. Therefore, the I is going to equal to 4. So the effective concentration will be 4 times 0.025. That's going to give you a concentration, effective concentration of 0.1. Okay, so the first one we got 0.04, second one got 0.06, third one got 0.1. Among the three, who is going to have the lowest freezing point? C, right? So it means actually, how many percent now? Oh, you changed a lot, huh? Okay, very last one. 0.04N of CaCl2. What's the I? 3, right? What's the concentration? 0.04, right? So the effective concentration will be 0.04 multiplied by 3, which gives you 0.12. Therefore, among the 4, which don't have the lowest freezing point? D. So the answer will be D. Okay. So if you understand this, okay, you can answer this type of question actually very easily. Every time you see this, right? You see this freezing point, boiling point, osmotic pressure, vapor pressure. All you need to know is first, when you have higher effective concentration, you are going to have lower vapor pressure, lower freezing point. You're going to have higher boiling point and higher osmotic pressure. That's actually the first concept that you should have. Second is actually to know how to calculate the effective concentration, which is your Markov coefficient I multiply your concentration specified inside the question. Okay, I hope this actually clear up this concept. Okay, you're going to see a lot of these type of questions in your homework and in your quiz. Cool. So this pretty much summarizes all the things that we talk about for chapter 10. Okay, but I still owe you the very last questions. By the way, the homework 2, which is chapter 10, is due on Sunday night. Okay, so make sure you do the homework as early as possible. Okay. Also, when is actually the first midterm? When is the first midterm? September 29, which is how many days? 25 days from now. Okay, so this is chapter 10, right? We still have chapter 11 and chapter 12 to go. Okay, so make sure you know how to actually arrange your schedule. That you can actually devote enough time for this specific course. Okay, any questions so far? So for now, let's finish the very last questions for chapter 10. Okay, so when 3 grams of a protein were dissolved in 50 ml of solution at 27 degrees C, the osmotic pressure was found to be 800 torr. Calculate the molar mass or formula weight of the protein. Okay. Third thing is that identify the keywords. What are the keywords here? Very good. Osmotic pressure. So once you see this, this tells you that this is actually a collective property questions, right? And then therefore, you know the equation that associated with your osmotic pressure will be pi equals to I m r t, right? So you know that is actually going to be the equation you are going to use. Okay. So once you see that, then that is actually okay. Go back and do our QD pack. Okay, what's the things we are looking for? The formula weight of your protein, right? What's that data? You have 3 grams of protein. So this means actually the mass of your solute equals to 3 grams, right? Then you have 50 ml of solution. That means actually the volume of your solution is equals to 50 ml. Converted to liters, it will be 0.05 liters, right? And then it tells you you are at 27 degrees C. That means the temperature is going to equals to how many K? 27 plus 273 K, right? That's 300 K. Okay. And then the very last one, you say the pressure is equal to 800 torr. But when we use this equation, what's the unit of your osmotic pressure? ATM, right? So you actually convert the torr into ATM, right? So that you know the pressure is going to equals to 800 torr divided by 760. Okay, so because 1 ATM equals to 760 torr. Okay, so to convert torr to ATM, you simply divide by your 800 by 760. Okay, so once you do like conversion, then you're going to get a value of 1.0526 ATM. Okay, so those are all the data that you have. Okay, then we start to have our plane, right? We know we're going to use pi equals to I n or t. Okay, so pi right now we know is 1.0526. What's your I? I is going to equal to 1. Okay, because the things that you have is a 14, right? I equals to 1. Right. So if you see the keyword like non-electrolyte, or any organic compound, and all proteins, they are all saying the same thing. The things that's relevant to you is that you know that I is going to equal to 1. Okay? So this is actually 1. Times molarity, right? Molarity, sorry. So times molarity. Molarity was defined as mole of your solute divided by the volume of solvent, a solution in liters, right? So the volume of your solution in liters is 0.05 liters. Okay, how do you calculate the mole of a solute? It will be the mass of your solute divided by its formula weight. Okay, so the mass of your solute is 3 grams, right? Formula weight is actually the one they want us to figure out. What's your R? Okay, this is actually the things that need to be careful, okay? 0.0826. Okay. So of course you're going to get these constants in your midterms, in your quiz, in your homework. Okay. The things you want to pay attention to is actually the unit. Okay, you're going to see the actual 2R value will be provided. Okay, one is actually the one with ATM in it. And let's say the one you need to actually use for the pressure calculation. Okay, what the temperature is going to be 300 K. Okay, so an equation with only one unknown. So I believe everybody will be able to solve this equation and calculate your unknown. So you can get the formula weight of your protein is going to equals to 1403 grams per mole. Okay, so this is actually how you solve this problem. Okay, concept-wise, it's always very simple. First, reading questions, find the keywords. In this questions, keyword is osmotic pressure. So like you know is selective property, right? And osmotic pressure, the equation associated with it is that pi equal to I times N times RP. Okay? You have to pay attention to the unit. Pi has a unit of ATM. R has a unit of ATM too. Okay, you have to use the correct R values. You know the definition of molarity. You need to know the temperature you need to actually use in Kelvin. Okay, so once you actually get those things put it together, you'll be able to simply solve the formula weight of the protein. Okay, any questions for this? Yes. So in the scientific calculations, okay, we don't really use degree C. Okay, we use Kelvin. Okay, so every time when you do the calculations, you convert it to Kelvin. However, sometimes the question will ask you the temperature in degree C at the end. Okay, so what you need to do is actually you need to do all your calculation in Kelvin, but when you provide the answers, you want to follow whatever was asked in the question. If the question is actually asking the temperature in degree C, then you need to actually convert your temperature from Kelvin to degree C at the very end. Okay, any other questions? So we're all good? Okay, that will conclude chapter 10. Okay, you have all the knowledge. Okay, you see many examples so far. You should be able to answer all the questions in your homework, in your quiz. Okay, and in your midterm. If you actually fully understand what we have done so far. Okay, so follow the logic. Okay, QD pad is actually very powerful. Okay, so if there's no more question for chapter 10, then we can actually head to the other things. I feel students may actually struggle a little bit. Okay, for chapter 11. Okay. So chapter 11 is all about reaction rate. Okay. Before we enter a chemical reaction, first, the thing to actually recognize is that when we write out a chemical equations, for example, this. Okay, lowercase a times capital A plus lowercase b times capital B, DUCG plus BE. Okay, so this is actually a general form of a chemical reaction, right? First things I want you to actually see from this equation is that how do we call the species? For example, the capital A and capital B. We'll call it as reactant. Okay, you need to see that very clearly. You need to know what, every time you see a chemical equation, you need to know what are your reactants. Okay, how do we call the species in capital C and capital D? Products. Okay, so every time you see a chemical reaction, it defines the reactants. It defines the products. These are the two things you will always write in your chemical equation. Okay, so let me write these things down. Okay, how the lowercase a, b, c, d coefficients. Okay, so to be more scientifically rigorous, we call it stoichiometry coefficient. Okay, but the word doesn't really matter, right? It's just coefficient. Okay. So okay. So okay, now we actually understand what a chemical reaction is by knowing all this definition. Okay. Then how do we actually define the rate of a reaction? So how are we going to define it? Okay, so the way scientists actually define it is actually very simple. Okay, so this is actually the rate. Okay, So it can define by the change of concentration over a period of time. So delta fraction means concentration over delta T over a period of time. Okay. So the concentration of what? Either the concentration of your reactant or the concentration of your product. Okay. So you see this delta A over delta T or delta B over delta T. We call it as the disappearance rate of your reactant. Okay, so you can use that to define your rate. You can also use the formation rate of your product. Okay, so either way will work. Okay. However, if you just simply do the calculation, it won't give you a unified reaction rate because you have the interference of all these coefficients, right? So let's say you have H2. That's okay. Let's say you have a reaction 1A plus 1B give you 2C plus 4B. Okay, coefficient wise, they are different. Okay, it means if you just look at the formation rate of your product, it's not going to be the same as the disappearance rate of your reactant. Okay, but it will be the same if you actually further normalize by the coefficient. Okay, so that's why you have all those coefficients then in front of it. Okay, so does everyone understand what I just said? Or you guys need some examples? Let's give you some examples. Okay, so in this case, your reactants will be Fe3 plus, Cl minus. Product will be FeCl3. Okay. When I write this in means actually at the molecular level, I need one equivalent of FeCl3, three equivalent of Cl minus. So I can just form one equivalent of product, right? That means, if just look at this, the consumption rate this term and this term, they won't be the same. Okay, because you need 3 of Cl minus for every single conversion. Okay, if this is the same, then you won't be able to make the conversion complete to give you the product. Okay, so it means actually this one will actually consume 3 times faster than your Fe3 plus, so that you can perform a product, right? However, when we talk about reaction rate, we want to have a constant numbers. Okay, to make it unified, what I do is actually I divide it by its coefficient. Then this rate and that rate will be the same. Okay, so that's the reason why we actually put the coefficient in the denominator in front of those delta concentration delta T term. Okay. Another thing that's very important that you should know is that when we talk about rates can only be positive. Okay, let's know negative rate. Okay, so rate, you only can actually have a value of positive, right? But remember, when we talk about this, the consumption rate or disappearing rate is always the final concentration minus initial concentration, right? So once it starts consuming, the final concentration will be smaller than the initial. Therefore, this term will be negative. Okay, but the rate is always positive. Therefore, we need to put negative sign for those consumption rates. Okay, so that the overall reaction rate is positive. Okay, so that's why it actually written in this specific rate, as in this specific format. Okay. Any questions so far? Yes. Louder. Okay. I'm getting really old. Can I repeat it? Unit one, do I put A, B, C, and D?
Yeah.
Because those are the coefficients in front of each species. How do we? No, you cannot, because like this, right? So A, B, C, D is just the coefficient in front of it. I put 1 here, I put 3 here. If you don't have problem with this, the next you wrote here, this is a general expression of life. All right. So if everybody is fine with this definition, I want to see, and I want to tell me what will be the unit of the overall reaction rate. Okay, so look at the definition. What will be the battery? Okay, I'm back. So what will be the unit? Yes. Delta T, T is what? The lowercase t. Time, yes. So molarity over time will be the unit of your reaction rate. So very good. So on the top is your molarity. At the bottom is actually the time. Time, typically you have the unit of second. Okay, so molarity over time will be the unit of your overall reaction rate. Okay, every time we talk about rate, okay, the denominator is always time. And typically have the unit of seconds. Okay, so this lowercase t, you want to differentiate from the uppercase t. Okay, the capital T typically stands for temperature. Lowercase t typically stands for time. Okay, so again, in Japan, or I guess in general, most of the scientific subjects, okay, there's actually some terms that you actually can't get used to it. Okay. But let's actually refer things that you want to know. The second thing that you want to learn today is the so-called rate law. Okay. So the equation we talk about is actually how people calculate the rate, reaction rates experimentally. Okay. But later on, we develop a theory called the rate law. So you can use the equation to describe all these behaviors. Okay. So the basic red law will have this format. The reaction rate can be defined as the product of K times A and B raised to certain power. Okay. This rate is exactly the same rate we talked about. So these two, they are the same. Okay. But here we introduce this little lowercase k. We call this lowercase k as rate constant. Okay. And then we write out these concentration terms, right? After the capital A and capital B, which in the equation we write, what is your A and B? Is your reactant. Okay, so this two is actually the concentration of your reactants. Okay, and it's going to raise to certain power. Right here we use M and M as the representation of the exponent. And those M and N are determined experimentally, which I'm going to show you an example how to actually get those two exponents from the experimental data. Okay. But one thing that you need to know is that when we write out this chemical equation, we put lowercase a, lowercase b in front of my reactants. Those coefficient is not the coefficient you can put on to your reactant concentration term. Okay, so you need to actually make sure you understand this. If I write out equation, when I ask you to write out the differential law of like equations, don't just write the coefficient on top of the reaction terms. That's not how you actually determine it. Okay. So this is actually the things that we want to actually do a lot of practice today. Okay. The other things that we want to learn is that in your homework, it will ask you the reaction orders. Okay, and those orders is actually defined by this lowercase m and n. Okay, for example, if today I write my reaction follow this differential rate law. Okay, if I say it's actually reaction, follow this differential rate law. The overall reaction rate equals to a rate constant K times A to the first power, B to the second power, C to the third power. Okay, then I will ask you what is the reaction orders of A. So which number should you actually use? 1. Okay. If I ask you what is actually the reaction orders of B, you need to answer 2. What is actually the reaction order of C? You need to answer 3. What is actually the overall reaction order? I will answer that. The overall reaction order will be the sum of all the coefficients you see, which is 1 plus 2 plus 3 equals to 6. Okay. Oh, the thing you want to pay attention to is that you need to listen very carefully to what is the actual order that the question is asking for. Okay. Let's do a few more practice. What's the reaction orders? So right now we're going to use this one, okay? The second one. What's the reaction order of A? 1. B? 0. Okay. C? Overall. Okay. That's a very simple definition that you can know. Okay. So with these simple examples, I think we can already go to a few questions. Okay, let's look at this. What is the reaction order of Br minus for reaction with the following red law? The rate equals to K times BrO3 minus times Br minus times H plus to the second power. So what will be the answer? 1, right? Because it specifically says the reaction order of Br minus. Therefore, you go to the Br minus term, right? And then you realize the exponent of that will be first order, right? So the reaction orders of Br minus is going to equals to 1. How about BrO3 minus? 1. H plus 2 overall 4. Okay, so this don't consider this actually a user question. These are questions that from the returns previously, right? If you know the concept, it's actually a very easy question to get your point. Okay, I want to make it clear. So for every single chapters, you see I provide a list of questions, right? Those questions was provided by the students. How is going to get those questions? From their homework, from their quiz, from their return. Okay, so when you take these courses, we're going to CASA take your returns. The way it works is actually you have a big data bank. Then the system actually randomly draw out the question from the data bank. Okay, so whatever I show you here are the questions within the data bank, meaning that you may encounter exactly the same questions in the future. Okay, so do pay attention to all these questions. Make sure you actually understand how to solve it. Okay, so let's go question number 1. Okay, so this is kind of like a little bit extension to the things you have learned so far. Okay, so it tell you consider reaction with this red law. The rate equals to K times Br minus times BrO3 minus times Br minus times H plus to the second power. By what factors does the reaction rate is going to change if the concentration of H plus is quadrupled? Okay, so this is kind of application of the things we have learned, right? So in the beginning, we know the rate is going to equal the rate constant K for the given concentration of BrO3 minus, Br minus, and then H plus squared. Okay. Even though we don't know the exactly numbers for the rate, but we know about this relationship, right? So what this question tells you is that if today I quadruple my H plus concentrations, right? That means what? The new rate, you can write the rate constant is a constant, it's not going to change. The BrO3 minus concentration is not going to change. The Br minus concentration is not going to change, right? But H plus concentration is going to be 4 times more, right? When we see this word quadrupled, that means right now is this, right? So this means this. Okay, so then you know you can just pull the things to the front. Okay, so you know it will be this times K times BrO3 minus times Br minus times H plus to the second power, right? And then we realize that this is this, right? So I just rewrite the things. Therefore, I know it will be this times your original rate. Okay, which you know the square of 4 is 16 times original rate, right? So the new rate is going to be 16 times faster than the original rate. Okay, so these are the little things that we want to become an expert. Okay. Go to the go through squares because you know your rate. Okay, your rate is depending on the proton concentration to the second power. Right? So these things I just distribute it to all the things happen inside that bracket. Then I move it into the very front. So I can actually put all the terms together to get back to my original rate. Okay, any other questions for this? So these are the simple questions that I want everybody to see. Okay. The very last question is actually I want to show you how do you get those exponents around the differential level. And this is the most typical questions you are going to see for chapter 11 in your homework, quiz, and midterm. Okay, so make sure you know how to do that. Okay. So the question is very characteristic. First thing first, I'm going to read the question for you, okay? Given the data below for the reaction 2A plus 2B give you 4C, generate D plus E plus 3F. The reaction is X1 order in A, X2 order in B, X3 order in C, and X4 order overall. And you want to solve X1 to 4, X1, X2, X3, X4 using the table below. Okay, so this is actually the most commonly seen question for chapter 11. And the main purpose is actually ask you to derive the differential rate law using the data provided. Okay, so if you look at this data, okay, you're going to have different experiments. Okay, so you have experiment 1 to 4. And in each experiment, it provides you the initial concentration of A, B, C, and the rate. Okay, so the very last column is actually your rate. Okay. So the way you handle it first is that check your chemical reaction first. That is actually your chemical reaction, right? 2A plus 2B give you 4C. Oh, sorry, 2A plus 2B plus 4C give you DE plus 3F, right? Well, every time you write out the red laws, you only use reactant. Okay, because reaction only depending on what reactant you put in first. Okay, so it's nothing to do with your product. So all these things, ignore it. But you know, A, B, C are the things you actually put into your red law. Okay. So the first thing you do is actually you need to know how to write out your differential rate law. It always follows this format. The rate is always the things that you need to write first. It's going to be equal to a rate constant K. Multiply the reactants. In this case, you have A you have B, you have C, right? And then you want to solve the exponent. In this case, the exponent you want to solve is x1 in A, x2 in B, and x3 in C. So this lecture, first thing lecture right out by yourself. Okay, every time you see that equation, you know the result must follow this format. Even though I don't know the order of x1, x2, and x3, that's okay. But I know the term I must have is the reactant terms, A, B, and C. There's actually one more thing you need is actually the rate constant K. So every time you see an equation, you can always write out the differential rate law in this format. Okay. So once you figure this out, then the next thing you do is actually I'm going to use this equation to rewrite my experiment. Okay. From experiment 1, we can say the chemical reaction rate, which is this guy, is going to give you 2 times 10 to the negative 3. It's going to equal to the rate constant K times concentration of A, which is this guy, 0.01 to the x1 power. Concentration of B, 0.2 to x2 has your concentration of C to the x3 power. Okay, so if you know how to write out your differential rate law, you should be actually apply to the experiment. Okay, then that's actually first things you want to write. Then you can actually write out the same for the 2. Then you know it will be 2 times 10 to the negative 3 equal to the constant K times 0.2 to the x1, 0.2 to the x2, 0.4 to the x3. Okay, so I just repeat the same process by using the condition of experimental 2. All right, so once you write out the second equation, I want to actually look at these two equations very carefully. Okay, so compare the terms one by one. Okay. Let's look at the rate. These two reactions have the same rate, right? 2 times 10 to the negative 3. What others are the same? The concentration of B, concentration of C, they are the same, right? K is the same. Okay, so the things you are going to do now is actually very simple. You are going to do the divisions. Okay, so what you do is actually I do equation number 2 over equation number 1. Okay, so when you do this, what do you get on the left hand side of the equal sign? This divided by that, it's just 1, right? Easy peasy. What happened to your K? K divided by K equals to 1, right? For your A, you're going to have 0.2 divided by 0.1 raised to the x1 power, right? How about your B? 0.2 divided by 0.2 to the x2 power. C, 0.4 divided by 0.4 to the x3 power, right? And we know this one will equals to 1. This one will equals to 1. This one will equals to 2, right? Therefore, you can write 1 is going to equals to 1 times 2 to the x1 power times 1 to the x2 times 1 to the x3 power, right? So if your base is 1, regardless what your exponent is, the value will still be 1, right? That means this will equivalent to that, right? So this tells you you can come to 2 to the x1 power equals to 1. Therefore, your x1 is going to equals to 0. Okay, because no matter what your base is, okay, if your exponent is 0, it will always give you the answer of 1. Therefore, you know your x1 is simply equals to 1. Right? So that's like how you solve the exponent. Oh, sorry, thank you. X1 equal to 0. Okay? So I run out of time. But the things you need to do, okay, do it at home. We'll come back to this one next in the next lecture. But do it at home. So what you need to do is actually repeat the same process. Okay, and figure out your x2 and x3. Then you can calculate your overall order. Okay, so we'll stop here. Thank you.
I had a question.